because we learned it. It makes, if you know what a parabola looks like, great. Then you can say, hey, that's a parabola. But what do you know about a parabola to know that that looks like one? The shape. Describe the shape. It's not a semicircle. Yeah. First of all, it says quadratic. You know that shape is a parabola. Great. Okay, so it's a parabola. What happens here? What can you say about the left side and the right side? They're the same. It's symmetrical about its... We know what this line is called now, except for Jeff because he wasn't here yesterday. This is called the axis of symmetry. Okay? If we have 2 points with an equal y coordinate, that's 4 for this point, that's 4 for that point, how can we find out where this axis of symmetry is? Yeah, think of that as average. If I take 6, okay, I got 6 on one test, I got 11 on another test. What's my average so far in this class? Divide it by, Alicia? 2, because there's 2 numbers. Okay, and that's 17 over 2. That's 8.5. Okay, that's where the x coordinate is for where my axis of symmetry is. And if we know where the axis of symmetry is, what else do we know? Where the vertex is. Okay? Because that's always at the same spot. It's either the maximum point or the minimum point. And the definition I said yesterday is, it's where this curve stops going in one direction and starts going in the other direction, where it kind of turns. Okay? So now we're going to really try to figure out what's this y coordinate where this x, I know x is 8.5. Yesterday we just kind of guessed. Well, let's just call it 4.5. Okay? Austin like 4 3/8. Okay? Tristan like 4 9/7. No, he didn't. 9 16ths. Okay, whatever. How do we find out exactly where it is? I'm just bugging you. Okay, relax. Well, can you see that okay? Yes. If I give you this, this is called an equation. Move that. And guess what equation that is? Guess which graph that makes if you plug it in your graphing calculator. This one. That's the equation for this graph. Okay? Now remember last chapter, linear inequalities. Could we find the y-intercept for this thing? What happens at the y-intercept? X is 0. Yeah. If I put, this is the y-intercept right there. If I put x is 0 here, what's y? What's this times 0 squared? Well, what's 0 squared? 0. Any number times 0 is 0, plus anything times 0 is 0. Hey, it's also 0, isn't it? Right? Okay, the x-intercepts, graphically, if you have it, I don't know where this one is, but there it is. Look, right? We're going to look further into that later on. What I'm trying to go back to here is, let's find out where this maximum is. I can do that on the graphing calculator, but algebraically, just like if you know if this is 0, you can plug it in. If I know that's x, if I plug that in here where x is, I'm going to find out that y-coordinate for this point, okay, by substituting it in there. This thing's big and ugly, but I actually, because that was our example yesterday, I came up with the formula, okay? They're not going to be this hard in the book, but Can you use your graphing calculator? Sure. Okay. What is negative 0.0606 times x is 8.5? 8.5 squared plus 1.0303 times x. You can go times or put in brackets. That'll tell me my y coordinate. Right where x is 8.5. Does that look like it's kind of right? Does that kind of look like 4.4? Sure does. You want to check, right? Okay, so substitute. I'm just going to write it out. 0.0606 8.5 squared plus 1.0303 8.5 gives me, let's just round it, 4.4. Okay? There it is. That's the y-coordinate for my vertex. Okay, it's an important point. That's the highest this thing ever goes. Okay, so the vertex as coordinates, vertex is always coordinates. That's the point. What else does that point help me with? Well, now I know exactly what the range is. Before we just guessed. Range is what again? All the y values of this graph. Domain is x, range is y. This thing goes down, you see the arrowhead? Forever and ever and ever and ever. It's everything from negative infinity up to this point. So for the range, I'm going to go y, it's all the values of y less than or equal to that point, where y is real numbers, right? All the fractions, all the decimals, everything. That's why this is a solid line. Okay? So we need that point. We can't guess it. Yesterday it was too much to introduce, right? We had domain, range, vertex, axis of symmetry. Okay? Today, hopefully, a day later, we're okay with doing that. Okay? So remember that. I said it yesterday's notes. Anytime you get 2 points where the y-coordinate is the same, well, this thing's symmetrical. Your axis of symmetry has to be halfway in between those 2 points. Okay, don't copy this down, but quickly, what happens if I got that point and this point? How do I know where my axis of symmetry is? Kind of looks like about here. Well, you need to know exactly where that is. This is -3. That is 2. How do I find out halfway between -3 and 2? That's -1, -1/2. Exactly, kind of right where I put my line. Okay, but that's how we find out for sure. You can't guess because it's going to be the middle of nowhere. Right? It's not going to be always your axis of symmetry on some nice, clear, defined point. Right? You got to figure it out. Just take the 2x coordinates with the same y value, divide it by 2. All right. One example. Because this is what your worksheet's going to look like. Graph that and determine vertex. What's A of S stand for? Axis of symmetry, domain, range, X-intercepts, Y-intercepts. Oh, there's so much fun stuff you can do with a parabola. Quadratics are joyous, aren't they? Okay. This is what your worksheet's going to be like. Okay, what's the quick way to do this? How do I graph this? You could make yourself an X and Y table. I'm giving you some, but remember, we should know how to substitute and put these numbers in there. You kind of want to know what's happening around the origin. So you go a couple of negatives, 0, a couple of positives. Hopefully that's enough. We can get a pretty good picture of our quadratic. Okay? Do you want to plot each one of these in here? Or do you want to use a nice technological tool to do that for you? Y equals, plug it in, x squared plus 2x minus 3. That's what it looks like, but I can't see the points on there. Is there a way to get the points off of this thing? The data points? Second function, table. That's cool. I showed you this the other day. Okay, just fill in your table. There they are. This way you're not going to make a mistake with your algebra. So negative 3 is 0. Negative 2 is negative 3. Negative 1 is negative 4. If x is 0, y is negative 3. 1 is 0, 2 is 5. And 3 is 12. Okay, that should be enough to plot this thing. You have the plot picture on your worksheet. It's going to look like graph paper, like this. Okay, so 1, 2, 3, 4, 5, negative 1, negative 2, negative 3, negative 4, negative 5. Negative 3, let me use red, is 0. Negative 2 is negative 3. Negative 1 is negative 4. 0 is negative 3. Is it starting to look like a parabola? Okay, if you get points that look like this, you gotta say to yourself, that's maybe I'm doing something wrong. Okay, that's not going to look like a parabola. Everything we do in this chapter, guys, is going to be a parabola. Okay, it's quadratics. Where was I? 1 and 0. 2 and 5. And 3 and 12, that's kind of like off my graph. So, do I think I got a parabola there? Don't even need this point. If you don't, maybe you want to plot another point here. Maybe you want to, I don't quite know what's going over here. Maybe you want to take another point. Put in negative 4, okay? Negative 4, 5. Negative 4, 5, that's up here too. There it is. 1, 2, 3, 4, 5, that's it. Okay? There's my parabola. Arrowheads, that keeps going forever and ever and ever. It's graphed. Now we got to find all this stuff out. Where do you want to start? Doesn't really matter. These are connected. Where you get this one, that's where you get this one. You want to start with domain and range because that's the funnest. Okay, let's start there. What's the domain of this guy? What are the x values of this graph? All of them. All real numbers. Every x value you could possibly think of, this graph will get to. Okay? Range. Do I have a minimum or a maximum? Minimum. It's all values greater than that point. What is that point? It kind of looks like I know what it is, but maybe I'm not sure yet. Okay? That looks like our minimum, negative 1, negative 2, negative 3, and negative 4. Can we assume that? Well, for now, maybe okay. If we know our vertex, we know that coordinate point. Okay? Maybe we should do that next. Vertex. It kind of looks like it's here, but how do we know for sure? Take 2 points that have an equal y coordinate. The x is -2, here it's 0, and divide by 2. That's -1. For sure, I know that's where my axis of symmetry is, okay? And I have this coordinate point, don't I? If x is -1, y is -4. I don't have to substitute it back in my equation. I've already got it, okay? But if you put -1 in here, of course, you're going to get -4 for y, all right? So my vertex is -1, -4. Vertex is always a coordinate point. It's always the minimum or the maximum. In this case, it's the minimum. Okay? So, check. Domain, now I know it's greater than -4. Check. Vertex, where's my axis of symmetry? It's always an equation. X is, well, where is it? I dashed it. -1. It's an equation line, okay? It's always, it's not just -1. That doesn't make any sense. Because it's not just that point, it's this whole line. That's where the mirror is, right? That's where the left side looks like the right side. Okay? Always an equation. All right, got that, got that. X-intercept. If you got a picture of it, look. Where does that thing cross the x-axis? There and there. And even if you don't have the picture of it, is that in our table? Where the x-intercept is, that's where y is 0. There it is. -3 and 1. Okay? It's right there, clear as day, in our table. So the x-intercepts, -3, comma, 1. Or -3 and 1. Those are the x-intercepts. If this is a written question on a test and you don't put x-intercept, if you just got -3 hanging out there in the middle of nowhere, and maybe a 1, does that look like a coordinate point? Yeah, it's not here. Okay? Be explicit. The x-intercepts, Mr. Watson, are -3 and 1 or -3 and 1. Okay? But it'll probably be multiple choice anyway. All right, y-intercept. Where does this thing cross the y-axis? Is it clear? Looks pretty clear. What happens at the y-intercept? X is 0. Do I have that point in my table? Okay. Do I even need to look here? No. Sometimes it's not going to be clear. It's going to cut halfway in between points. You're not sure where that is, but you can always substitute x is 0 in here. Y is 0 plus 0 minus 3. The y-intercept is -3. Hey, there it is. Okay? So you can still do it the way you did it last chapter. If you don't have the data table, if you don't see the point here, clear as day, the y-intercept is -3. Okay? Lots of stuff to know, and we're not even halfway done what we can know about a parabola and a quadratic yet. Alrighty? Worksheet, 2 marks. Get it in as soon as possible. Just time enough to do it today.